Here we're going to look at the technique for writing more complex half equations. We've got a question where we've got to write a half equation for the conversion of dichromate ions into chromium 3+ ions. So we've got these dichromate ions into chromium ions. So let's write down the reactants and products. We've got my dichromate ions and they're converted into chromium 3+ ions. But obviously this is not balanced, and what we're going to look at here is the technique of how you get that half equation to balance. First thing you look at is balancing the atoms undergoing redox. The chromium is the atom undergoing redox. It's the atom which changes oxidation state. We can see that we've got 2 chromiums on the left, but only 1 chromium on the right. So the first thing we need to do is balance the chromiums. This stage is not always necessary because in a lot of half equations the atom undergoing redox is already balanced, but it is the first thing you need to be looking at. Are the atoms undergoing redox balanced? So we've now got 2 chromiums on the right hand side to balance my 2 chromiums on the left. The next thing we need to do is balance any oxygens with water, and we can see that the left hand side has got 7 oxygens and the right hand side has got 0. So I need to balance those oxygens by adding water. So I need to add 7 waters to the right hand side. By adding the waters, now I need to balance the hydrogens. I've now got 14 hydrogens on the right, no hydrogens on the left, and I balance any hydrogens with hydrogen ions. So I now need 14 hydrogen ions on the left hand side. Now this equation now is balanced in terms of atoms, but it's not balanced in terms of charge. The left hand side here has got an overall charge of 12 plus. We've got the 14 pluses here and with 2 minus there, and that gives me a charge of 12 plus. The right hand side of the equation at the moment has got a charge of 6 plus because of these 2 3+ chromiums, and we need to balance the charge by adding electrons to the side with the largest positive charge. So we've got to in effect get both sides to equal 6 plus by adding electrons to the left hand side. And how are we going to get both sides to equal 6 plus? We add 6 electrons. And that now gives me the overall half equation for this reaction. So we can see now that both sides have got a charge of +6. We've got here a reduction because the electrons are on the left hand side, and we can kind of check this 6 electrons. Is that correct? Is that the right number of electrons I've added? We can check that by looking at the oxidation states. We've got chromium atoms of oxidation state +6, and we need to get them to be equal to be +3. And in order to do that, we've added 3 electrons to each chromium to get the 2 6+ oxidation state chromiums to +3. In order to do that, I need to add 6 electrons. So I'll just check that. So I've got 2 + 6 chromiums, and I need to add 3 electrons to each, which is a total 6 electrons to get both chromiums to be oxidation state +3. So that is how you balance half equations.